Hello, I wanted to spend a few minutes showing you what we mean when we use the different language related to transformations. For example, we talk about shift, we talk about vertical stretch, horizontal stretch, etc. Especially the vertical and the horizontal stretches and shrinks. They can be a little bit hard to visualize, and it's definitely easier to apply those when you know what the picture is supposed to look like at the end. So I am working with the graph of y equals x squared. And you can see I have the graph of x squared as a dotted line, and in this picture you see the graph of x squared shifted up 2 units. And so you can see the red point gets lifted up 2 units, the green point gets lifted up 2 units, the blue point gets lifted up 2 units, etc. This should be pretty straightforward. So in this case I have the graph shifted down 3 units. Here I have the graph shifted right 2 units. And here I have the graph shifted 4 units left. Okay, so all of these should be pretty straightforward. You probably have remembered these from earlier classes. It gets a little more interesting when we stretch and shrink. Here is a little diagram that I've drawn up to help visualize the vertical stretching and shrinking. This is a piece of the Transforming Overview document that is available in the Google Drive folder. So in the left-hand side, we have the horizontal shrink and stretch. So you can see in both cases, the y-axis is going to be fixed. You can see that the y values of each point does not change. It's only the x values for each point that we change. So if it's a horizontal shrink, your graph is going to be pushed towards the y-axis. If it's a horizontal stretch, your graph is going to be pulled away from the y-axis. If you have a vertical shrink or vertical stretch, in this case the x-axis will remain fixed and the x values don't change. So for a vertical shrink, your graph gets pushed towards the x-axis. So when we stretch vertically, the x-axis is fixed and the graph is being pulled away from the x-axis. So in this case, we were stretching by a factor of 2. So the y value of every point got multiplied by 2. Notice that the x values do not change if it is a vertical stretch. The y values get multiplied. In this case, I have a horizontal stretch by a factor of 2. So in this case, each of the x values get multiplied by 2, while the y values of the points remain the same. In this case, the y-axis is remaining fixed, and the graph is being pulled away from the y-axis. So here we have the graph being shrunk vertically by a factor of 2. So all of the y values have gotten multiplied by 1/2, which is the same as saying they were divided by 2. You can see that the x-axis is fixed because it's a vertical shrink, and the graph in this case has been pushed down towards the x-axis. And here we have a graph being shrunk horizontally by a factor of 2. So in this case, the x values all got multiplied by 1/2 or divided by 2, however you choose to say that. So the y-axis remained fixed and the graph got pushed towards the y-axis. And I wanted to make one last point. It can be difficult to look at a graph and determine whether it was a vertical stretch or shrink versus a horizontal stretch or shrink. For example, this graph is pulled away from the y-axis, but it looks like it is pushed towards the x-axis. In this case, the graph is pushed towards the x-axis, but it also looks like it's been pulled away from the y-axis. So you will have contextual clues that will allow you to discern between the two. If you look at this graph, if you pick a particular x and look at the ratio between those y values, the ratio will remain the same every time you do that. On the other hand, if you picked a particular y and looked at the ratio between those x values and then did it again for another y value, the ratio between those x values will not be the same. So that's how we know that it was a vertical transformation as opposed to a horizontal transformation. So hopefully now you have a little bit better feel for what these different transformations are supposed to look like.